Hey there, AP Stat students. We're going to continue here with section 4.2 and experiments. We can't just do comparison alone. We have to randomly assign. So we're going to talk about the way that is done. Whether you are randomly assigning in a study or an experiment, both apply, but we're more specifically talking about it here in experiments. So how random assignment works, we're going to talk about three different methods. This year, the high school has enough budgeted money to compare the online SAT course with the classroom SAT course. 50 students who have agreed to participate in an experiment comparing the two instructional methods. That being said, 50 students, we would hope that they are of similar background, but they do not have to be, since we are going to randomly assign them. If we did it that the first 25 that signed up would do this and the second 25, that would not be a good random allocation. So we're going to describe how you would randomly assign 25 students to each of the two methods. So our first way is using 50 identical slips of paper. We basically would number slips of paper from 1 to 50, and we would have students pull out a number, or we would pull out the numbers for the students. The other way we could do it is we could write their names on 50 slips of paper and then pull out the first 25 are in this group and the other 25 are in another group. Or we could alternate. You pull out one, they go in the first group. You pull out the second one, they go in the second group. So you can choose to do either way. It doesn't matter whether you choose one at a time for each group or you choose all the 25 and the other 25 go into the other group. That is how you would do it by identical slips of paper. So we're going to talk about the technology method. So I have my calculator pulled up. On our calculator, I guess I need to expand this just a little bit. Let me pause for 1 second. Okay. So we go to RandInt. RandInt is under Math Prob. Random integer is what it stands for. So RandInt. Let's go back there. So our lower number is 1. That's the first person that could be chosen. How many people are there? There are 50. You're going to assign 25 to each group. How many are you going to choose? 25. So we're going to choose 25. So then we would paste that. So these are the people. So the one thing that we have to make sure we identify, if we're doing it this way, we have to make sure that we have given everybody a number. Doesn't matter, that's not the random part. If you're going to use the calculator to randomly decide, everybody, whoever shows up first gets number 1, whoever shows up last gets number 50, or however you want to give them their numbers, that's okay. You could do it by alphabetical list, whatever is more convenient. But then the randomness comes from the calculator randomly selecting numbers. So we would go through 24 is part of the group, 19, 20. Now you might see, ooh, 20 got selected twice. Basically, we would go through all of these numbers. We have to see if any other numbers are repeated. I see another 20 in there. So you go through, and if there's any repeats, you would just have to do random int again. There, I did it again. So let's just say, for example, 22 people got selected out of the first 25 here. Then you would just go and select the next 3. Or however many repeats you had up here, you would just go do it again and select those. You just ignore repeats, because a person can't be selected twice. So they just get ignored. Okay, so that's kind of the way the random integer function works on the calculator. That is one way of doing that. The other method, or the last method of using the table D, it's in the back. They call it table D. It's actually on T5. It's going to be tough for me to show you that page, but it's just a list of random numbers. You have to assign everybody a number. And in this case, everybody gets assigned a number from 0, 1 to 50. You have to do 2 digits. And then you would just go through and select the first 25 numbers. You'd go select 25 numbers until you get, they would maybe tell you to start on a certain line. And I can show you in class what this table looks like. Or you can look it up in the back of the book. It's table T5. And you just go until you have 5 numbers, or 25 numbers selected. And if you get repeats, you exclude them. You're going to get numbers that are bigger than 50. So you might have an 87 come up or a 56. You just ignore them. You don't even pay attention to them. You just keep skipping until you get 25 different numbers out of your list. So that would be our third method of choice. Typically on the AP test, they don't ask you to actually do the selection process. Like, they're definitely not going to make you put slips in of paper in a hat and select. The technology and the table, they usually just want you to set it up. They don't actually make you do it. So just talking through or writing through what you should do is really all you have to do in this case. So that's how you randomly assign. So what we need to do in a really good experiment is that you need a control and you need to replicate. I think we'll have a warm-up later that might ask that question. But we need to randomly assign and create 2 groups of students. In another experiment, you may be assigning them to 3 or 4 groups, but in this particular SAT course example, it's 2 groups. The control group is what they've used to do. They're comparing it as to the instructor teaching it. They want to know if the online class is any better or not so good or whatever it is. And then we need to assign students to each group. This is the idea of replication. You're not just doing it for 1 or 2 people, you're doing it for 25. Now, if we really want to replicate it, we should then repeat the process maybe next year and the following year. Don't just go by 25 students compared to another 25. But for right now, that is replication. When you're making an experiment, there's certain principles. Comparison. We need to be comparing 2 or more treatments. When we say treatments, one of them can be a placebo. So it can be a fake, or it can be the control group. Placebo is a control group. Sometimes a placebo, we talk about a placebo group with medicine. So it doesn't always have to be just with medicine. We need to randomly assign. We need to control, keep other variables from affecting the response. So we want to try to have a control group to do that. And then we need to replicate. So here's an example. I will pause this so you can read it, or you should pause it at your seats or at home so that you can read the experiment. So I will do. Okay, hopefully you've had a chance to pause, take a look and see at the 4 principles of this designed experiment. For comparison, the researchers used a design that compared both the active treatment to a placebo. So again, you have your control group, your placebo group, and your treatment. Random assignment was used, each of the 4 treatment combinations. So they randomly assign, so there's no bias there. Control, the experiments use subjects of the same gender and occupation. So that's always something you want to be aware of in terms of making a controlling other variables. You want to make sure that that happens. Not just a control group, but controlling other variables. And then replicate the over 500, I'm sorry, not 500,000, 5,000 subjects were used in each treatment group. So that's a good number to make that happen. So those are your 4 things that you want to look at. So here's a completely random design. It's a little diagram, which can be used on the AP test, but there are some other things on the next slide next slide or 2 that talks about other things you want to do. So you take your students, you randomly assign them into 2 different groups, you give them the treatment, and then you compare the results. So this is a nice flow chart way of looking at it. So in a completely randomized design, they are assigned by chance to the different groups. So in this little AP exam tip, if you're asked to describe it, you won't get full credit with just a diagram. You're expected to describe how the treatments are assigned to the experimental units and clearly state what will be measured or compared. So I need to explicitly write out these arrows. How did I do this? So I said previously in the video, I would give 0, 1 to 50 would be the numbers, and then I would randomly select 25 students that go into group 1, and the other 25 would go into group 2. And then we give them the treatment, and then what are you comparing? Not just compare SAT, what are we comparing? We're comparing the online SAT with the traditional in-class SAT prep course, and then we make our comparison and go from there. Okay? check your understanding. So I'll go ahead and pause. Okay, hopefully you had some time to look at that. If not, pause it and take a look at it again. So you're going to randomly assign the 29 students to two treatments. So 0, 1 to 29 is what you would do if you're using the random number table, or you could describe how you would use the random int function. You're going to evaluate the performance in small groups or evaluating the performance alone. The response variable will be the accuracy of their final performance evaluations. So you want to have them in the best way possible. You're going to have 15 and 14 obviously into each group. You can't have it evenly split, but you never want to do it like 20 and 9. That wouldn't be a good way to divide it. Okay? So if you wanted to use the paper method, the hat method, you can use that as well. You put the names of students in a hat and draw them from there. What is the purpose of the control group in this experiment? It's to provide a baseline for comparison. So without a group to compare, it's impossible to determine if the small group treatment is more effective. So you need to have a control to make that comparison. So what are some things that can go wrong? So medical experiments, we need a placebo. Can't just give nobody, can't give a group nothing, because then they're not going to think that anything's happened. So is it just mind over matter? The placebo effect is a sugar pill. It's a dummy treatment. So because I'm taking this pill, I'm going to lose weight, have better blood pressure, sleep better at night, whatever it is. So they always have to have a placebo in medical experiments. Double blind is when the people that are doing the experiment don't know who got what treatment. That's usually better for when it's a subjective test. Again, looking at somebody that took a medication to see if they are less hyperactive. Hyperactive is a little more relative. If you are just doing it for blood pressure, that's pretty cut and dry. Your blood pressure is what the blood pressure is. There's not much interpretation there, so that's not necessarily a need for a double-blind experiment. Single blind, you don't look at it until the ending results, basically. Okay? A lot of single-blind experiments, again, are on the objective side, whereas we can measure how much weight did they lose and that kind of stuff. But the subjects can't be aware what they are receiving. So otherwise, they would definitely know. If you knew you're getting a placebo, why would you take it? All right, last, check your understanding in this little section. So go ahead and pause and try to answer these questions. Answer number 1 is no. Why is this important? Perhaps seeing the image of their unborn child encouraged the mothers who had an ultrasound to eat a better diet, resulting in healthier babies. So that's not the only reason. You can come up with some other ones, but that's a possible reason. Was the experiment double-blind? No. While people were weighing the babies at birth, may not have known whether that particular mother underwent an ultrasound or not. The mothers knew. So it's not a double-blind. So here's an example where the person doing the experiment didn't know. So it's not a double-blind. And then number 3, based on your questions to 1 and 2, describe improved design for this experiment. You could treat all mothers as if they had an ultrasound. But for some mothers, the ultrasound machine wouldn't be turned on. So you could just pretend they were getting an ultrasound. Or you could turn on the machine, but just not actually put it on the mothers. So just little things like that to try to make it work. All right. If you have any questions, let me know. Assignment to follow.